What if I told you that the core technology that's processing your bank transfers, your ATM withdrawals, and your credit card swipes is actually a direct descendant of a system that was born over 60 years ago? Yeah, it sounds pretty crazy, but it's true. So let's pull back the curtain on the invisible engine that runs global finance.
I mean, really think about it. When you tap your card at a store or you check your balance on an app, what is actually happening behind the scenes? It's not all shiny new cloud servers and trendy startups. Nope. The real workhorse is something much, much older.
Okay, get this. A staggering 95% of all ATM transactions rely on this one technology. The vast, vast majority of cash withdrawals happening all over the world are processed by a platform with roots that go back decades.
And it doesn't stop there. Not at all. Over 80% of in-person card sales are also supported by this very same system. It's one of the most critical, yet completely invisible pieces of our daily lives. So, what is this hidden giant? It's called IBMI, though you might have heard of it by its older, more famous name, AS/400. For decades, banks have put their complete trust in the server platform for a few really good reasons. It's legendary for its rock-solid stability, its intense security, and its sheer power to just churn through massive volumes of transactions without even breaking a sweat. So how on earth did this one system get so deeply embedded in the world of finance? Let's dig into why it became the invisible backbone of the entire industry. You know, it really all comes down to trust. Banks need a system that simply cannot go down, period. And this platform delivers that kind of near-perfect uptime. It can handle thousands of transactions every single second with security that's built in from the ground up, not bolted on later. Plus, it has decades of proven reliability, and it meets all the strict compliance standards, like PCI DSS for payment cards. For a bank, that's basically the perfect resume.
Okay, but here's the catch. Here's the conflict in our story. This incredibly reliable system is facing a very human problem. The experts, the people who built and maintained it for decades, well, they're starting to disappear.
Just take a look at this. This chart shows the experience level of developers who code in RPG, which is the main programming language for IBM I. A massive 72% of them have over 20 years of experience. Now, on one hand, that's incredible expertise, right? But on the other, it signals a huge knowledge gap coming over the horizon as these folks begin to retire. And Deloitte just puts it perfectly here. This isn't just about losing coders. It's about losing decades of institutional knowledge, the why behind how a bank's unique systems actually work. This is a quiet but really serious threat to the whole financial industry. Now, the logical question is, right, if the experts are retiring, why not just get rid of the old system, replace it with something new and shiny? Well, as you can probably guess, it is not that simple. For bank, replacing its core system is basically the equivalent of performing open heart surgery. It is incredibly risky, it's astronomically expensive, and if something goes wrong, it could literally break the bank. This isn't just an upgrade, it's a bet the bank gamble that most places just are not willing to take. This really leaves banks with a choice: replace or modernize. Replacing is that high-risk gamble that throws away decades of proven business logic that just works. Modernizing, though, that's a strategic evolution. It lets banks keep their most valuable, time-tested systems while integrating new technologies around them. It's like a skyscraper's foundation. You don't rip it out, you build on top of it. And this is where the story gets really surprising. This old system isn't just fading away. No, instead, it's going through this remarkable transformation. This old dog is learning some seriously new tricks. This whole metamorphosis is happening across 4 key areas: moving to the cloud, using APIs, speaking modern languages, and adopting new ways of developing software. Let's start with the cloud. That's right, these powerful servers are no longer stuck in some basement data center. Banks are now running their IBM I workloads in hybrid cloud environments, connecting them directly to services on IBM Cloud, Microsoft Azure, and even AWS. So they get the best of both worlds, the rock-solid stability of the core system and all the flexibility of the cloud. What we're seeing is this fundamental shift from a closed-off, monolithic box to an open, connected hub. By using modern APIs, which are kind of like secure doorways for software, banks can connect their core systems to mobile apps, to web portals, to anything really. This enables real-time integration that was pretty much impossible before. And to solve that whole talent problem, Well, IBM I now runs modern open-source languages natively. You can run Node.js, Python, PHP, and Java right on the same machine as your 30-year-old code. Even its own traditional language, RPG, has been completely modernized to look much more familiar to a new generation of developers.
And look, this isn't just theoretical. A developer today can write a simple Python script, just like this one, to connect directly to the IBM I database. This means someone who has never even seen an AS400 can use the skills they already have to work with its data, which is huge for bridging that generational gap. Finally, the whole development process itself is catching up. Programmers are now using the exact same modern tools for collaboration and automation, like Git and Jenkins, as any other software team. They're moving away from old-school green screens to modern coding environments. So in short, developing for this platform now feels just like developing for any other modern system. So what does all of this mean for the future of banking technology? Well, it points to a hybrid model where old and new don't just coexist, they actually collaborate.
So yeah, the future of banking tech isn't some dramatic rip-and-replace movie scene. It's all about smart integration. It's about taking the unbelievable reliability of a legacy core and powering it up with the agility of modern cloud technologies. This is evolution, not revolution.
And that leaves us with a final thought, doesn't it? We've just seen how this financial bedrock is adapting instead of dying. So it really makes you wonder, what other critical so-called legacy systems in government or logistics or healthcare are quietly being modernized right under our noses, getting ready for the next 60 years?